All right, everyone, welcome back. We got 9.2 Trig Identities Part 2. In this lesson, we're going to do the same thing we did last lesson. We're going to verify trig identities are equivalent through substitutions, but we're going to be focusing on problems that require different ways to solve them, or just some of the more hard ways to solve. So some of this stuff you would have seen in the last lesson, but we're going to continue to practice those types of problems. Now, this first one here, all right, and I got a we do on every page because as I decide I might throw one your way, we want to verify that the left side is equal to tan squared theta. Okay. Now, a good way of trying to solve these problems is to look at each one and think about what you could write it as. So we see secant squared theta. I know that secant squared theta is going to be equal to tan squared theta plus 1. That might be helpful because I know we got a tan over here. And then I see 1 minus the cosine squared theta. And I go over here to my other ones, and if I subtracted this cosine to both sides and solved for the sine squared, I would have 1 minus cosine squared theta. So which one do we choose, right? Well, if I look at secant, right, secant is going to be 1 over cosine. So, I don't think changing this is going to be helpful yet. I think that if we change this secant squared theta to be 1 over cosine squared theta, then all of a sudden I have this whole left side in terms of cosine squared theta. And maybe I can multiply it in, all right? Now this is all kind of speculation at this point, but let's see what we can get here, okay? So let's write that as 1 over cosine squared theta times 1 minus cosine squared theta is equal to tan squared theta, okay? I'm going to multiply this in, all right, and I'm going to get 1 over cosine squared theta minus cosine squared theta over cosine squared theta, okay, is equal to tan squared theta. All right, now we know that that will cancel, and it'll leave me with minus 1. Now, you may be going, well, then what do we do with this cosine? Well, let's bring it back to a secant, okay? And that might seem trivial to do, okay? But look at this. Secant squared theta is equal to tan squared theta plus 1, right? So if I add this 1 to both sides, I'm essentially getting the same thing. Or if I solve for tan squared theta here by minusing 1 to both sides, tan squared theta is equal to secant squared theta minus 1. So I can write this as tan squared theta is equal to tan squared theta. So I've proved that to be true. Okay. Now, why did we have to change this? Well, we didn't have to at first. We could have multiplied it in as a secant squared theta, but then you would have had cosine squared theta divided by secant squared theta. It would have been a little bit harder to see maybe that would cancel out. Okay. So by writing it this way, it just, it helped us see that we could cancel those out. And then we were able to bring it back to a secant squared theta and use our trig identity here to show that tan squared theta is equal to tan squared theta. Okay, a little bit tougher, right? Some of those early assessments we made, we could have changed this one off the bat, right? But would it have been helpful? Maybe, maybe not, all right? Okay, let's go to the next one. I want you guys to give this one a try, all right? Oh, you know what? Actually, yeah, give this one a try. See if you can figure this one out, and then I'll go over it, okay? So pause it and give it a try. All right, hopefully you guys got that one. This one you got to think a little bit outside the box here, okay? We want to show that 1 divided by tan x plus tan x is equal to 1 over sine x cosine x, right? Now, one thing we haven't really done before is actually gone ahead and add these terms together. All right, we see that it's 1 over tan x plus tan x. We know that they don't have the same denominator, so we can't add them yet. So let's give it the same denominator. All right, in order to do that, I would have to multiply tan x by tan x over tan x. And so what I mean by that is I would put 1 over tan x plus tan x multiplied by tan x over tan x. Remember, if I'm trying to get this term to have a denominator of tan x, I have to multiply the numerator and the denominator by that. And this would be equal to 1 over sine x cosine x. Okay. Now I actually go ahead and do the multiplying. I get 1 over tan x plus tan squared x over tan x equals 1 over sine x cosine x. All right. Now that might have not been easy to see. You may have gotten stuck in trying to maybe change some of these things. And you know, that could have worked out too. But if you would have changed this to sine over cosine and this to sine over cosine, which more this would have been like a cotangent, you know, you still could have gotten to this. All right, so there are more than one ways to do this. This is just, I want to make sure that you know that you can do this right here. Okay, now we add this together, we get 1 plus tan squared x divided by tan x is equal to 1 over sine x cosine x. Okay, now this should be triggering like, I know that that's got to be something, right? So 1 plus tan x, let's see, is also secant squared x, okay? And secant squared x, once we have that, can also be 1 over cosine. You see that? And I see that I do have a 1 over cosine here, so that could be helpful. So let's dive into this. Let's rewrite this. Let's do them both. So we first said it could be secant squared x over tan x is equal to 1 over sine x cosine x, okay? And I am running out of space. Let's fix that. Let's see, resize, there we go. Ha, love this, okay. All right. So we're gonna have, okay, so we would get this, and then we also said that we could rewrite that as 1 over cosine x. It is a squared, so it would be 1 over tan x times cosine squared x is equal to 1 over sine x cosine x, okay? Now we're getting there, right? We can start to see that we're close, but we have a squared here. So let's move on our tangent, or our tan x here, okay? 1 over tan x, let's see what that's also equivalent to over here. It's also equivalent to cotangent x, right? Well, cotangent x is also equivalent to cosine x over sine, or excuse me, cosine theta over sine theta. Same thing if I say x, right? So, you know, I'm jumping through two hoops here. I'm saying that 1 over tan x is cotangent, and then I'm using the other cotangent, cosine over sine. So I'm doing two steps at one. So I'm going to rewrite this as cosine x over sine x times cosine squared x equals 1 over sine x cosine x. Okay, that cosine and that squared cancel, and so I'm left with 1 over sine x times cosine x is equal to 1 over sine x cosine x, so it is correct. Okay, so exactly what we wanted to see. A lot more steps on this one though. All right, your biggest takeaway needs to be that you can do these steps. All right, that you can, get like denominator, add them, and move forward. All right. Okay, this one's a little bit, this one's a good one. I think you guys can give this one a try. Why don't you guys pause this one and give it a try. All right, so hopefully you guys got this one, right? You can see that we have cosecant of n minus cosine n times cotangent n is equal to sine n, all right? So let's start thinking in terms of our trig identities. We know that cosecant n is going to be, where are we at? Cosecant, the same thing as 1 over sine, so that's helpful. And cotangent, it can also be the same thing as cosine over sine. So let's rewrite it in those terms. So 1 over, where are we at? Sine n minus cosine n times cosine of n divided by sine of n. It's so hard to remember that these are n's here. Okay, is equal to sine of n. Now we know that we have cosines kind of next to each other here. That's probably going to be just a cosine squared. So let's simplify that. And I'm going to start using x because I feel like the n's kind of next to each other. It's just weird. So I'm going to use x. But it would be n, right? So sine of x minus cosine squared of x divided by sine of x is equal to sine of x. All right. Now look at this. we have the same denominator, so we already can write the top as 1. 1 minus cosine squared x divided by sine x is equal to sine of x. All right. Now, 1 minus cosine squared x, that needs to trigger to us that there's an identity for that. Remember, sine squared x would be the same thing as 1 minus cosine squared. Okay. So this is the same thing as sine squared x, which hopefully you can see these things starting to click. Okay. So the square would cancel out, right, with the bottom one. And I would just be left with sine, let's put it back in n, because that's what it was supposed to be, sine n equals sine n. And that's it. Okay. So again, notice that we're dealing with, these like denominators, bringing them together and simplifying from there. All right. A lot of these problems have these Pythagorean identities. It's just what it's going to be. Okay. All right. Now here's the last problem that we're going to do. Okay. I do want you guys to pause and give it a try, because I think it's helpful to try it even if you're not going to get very far, and then see what the solution is, so you can see where your thought processes were different. But you do need to know that this is supposed to be a power of 4 here, not a power of 2. So make sure you write that in. Okay. So I want you guys to go ahead, pause this, and give it a try. Okay. So we see that we have, cotangent squared and a cotangent squared here, right? We have cosecant squared, and then of course we have cotangent to the power of 4, all right? A little bit different. We haven't seen that yet, and that's okay. All right, we can still deal with these. All right, so we need to prove that this left side here is the same thing as cotangent to the power of 4 theta. All right, now if we look at this, of course that we can change cotangent, we can change cosecant, we can change cotangent, but I want you to think of this differently. You have a term here, and you have a term here, and they both have cotangent squared theta. So take those out. Divide out the cotangent squared theta from each problem. Okay, so that I'm left with, let's increase the thickness. Okay, I'm left with cotangent squared theta multiplied by cosecant squared theta minus 1 is equal to cotangent to the power of 4 theta. Now again, we see this cosecant squared theta minus 1. Let's go look over here. We do have 1 with cosecant. If we minus 1 to both sides, cotangent squared theta is equal to cosecant squared theta minus 1. So this piece right here is the same thing as cotangent squared theta. So now I have cotangent squared theta times cotangent squared theta is equal to cotangent to the power of 4 theta. And of course, just like if this was x squared times x squared, it would be x to the power of 4, right? So same thing here. Same thing here. Okay. Wow, eraser. Okay. Okay, just in case you didn't know, like if you tap the pencil, it switches, and apparently I tap the pencil a lot. Okay. So we get cotangent to the power of 4 theta is equal to cotangent to the power of 4 theta. So we have proved that identity to be true. That's a check mark. Okay. And that's it. Okay. Now, practice makes perfect on these. Having these up and available will help you be more successful. It will take time to see these relationships, but keep practicing. Okay. That's all I got for you guys. Hope you guys have a great day, and I'll see you next time.